Let's begin with a look at the series of atomic absorption spectrometers available from Buck Scientific, starting with our 210 series AA, which is capable of normal flame operation, nitrous oxide, hydride and cold vapor generation, and graphite furnace to provide the greatest sensitivity and highest accuracy based on the unique background correction of the 210 instrument. This is the Buck Scientific Model 210 Atomic Absorption Spectrometer System. This chassis is used for several products, and we will demonstrate how simple and easy it is to use and the high quality of the data you can obtain from it. Before any atomic absorption analysis, you must select the hollow cathode lamp for the element of interest and insert it into the turret so that it can be powered up and brought into alignment with the flame. Once that's done, you will go to your library and, using the keys according to the procedure, select the element that you want to do for this particular analysis. Pressing the library key, you can see what element is loaded into lamp 1. Since we're doing copper, and that was previously done, we're all set to do our alignment. Press the escape key, and then the align key, and using the wavelength scroll on the right side of the instrument, set the wavelength and slit as specified so that the bar graph or the numerical value shown in the top of the screen shows the highest value. With just minimal training, this procedure should take no more than 15 to 30 seconds. When you're done, press the Auto 0 key, and we'll be ready to begin our analysis. The Buck 210AA incorporates a high-impact bead nebulizer, which allows virtually any solution of high-dissolved solids or organic matrices to be aspirated and analyzed accurately. To begin setting up the AA for the analysis, turn on your air supply, which could be from an air compressor supplied by Buck Scientific or a high-pressure cylinder. Lift the lever for your acetylene gas tank, which is the approved fuel for AA, and proceed to light the flame. You can see that our normal conditions include a balanced or lean flame, which is suitable for most of the elements of the periodic table. All of the Buck AAs are also capable of running nitrous oxide for those high temperature elements as needed. Close the door on the safety shield, and now we can begin our calibration prior to analyzing a sample. By pressing the Cal key on the keyboard, we go into our calibration screen. And the system is capable of storing previous analyses, so it's very easy to refresh or recalibrate on an existing curve. With your sample in the blank, press the Start button and follow the directions on the screen. The system will auto zero on your blank and then prompt you to take replicate readings of your standard as defined by your procedure. In this case, we're taking 2 readings of each standard, and the average value will be used to calibrate the system, in this case for copper. The data from the calibration can be directed to an ASCII file on a PC for incorporation in your LIMS software, or the Buck Analyze program, or taken to a printer. When this is finished, we can press the Cal key, the Yes key to see the coefficients for the curve, and then Enter to actually see our calibration curve. And as we can see here, we have mostly a straight line, although the software is capable of doing a second-order quadratic curve fit for any data points entered into the system. If you're satisfied with the appearance of the calibration curve, press the Escape button 3 times. Returns you to your active analysis screen, and we recommend rinsing with the blank prior to analyzing a sample. The stable beam, single beam design of the Buck 210 series instruments is remarkably precise, as seen by the extremely low level of drift in our deionized water blank, shown by the 0.00 part per million reading on the screen. Normally, this would vary by as much as 0.02 ppm, or the equivalent of 0.02 absorbance. Thus showing the stable beam design of our optics is equivalent to those of the lower energy double beam designs. At this point, being satisfied with our calibration and validating the stability of the system, we can stick our sample tube into our sample, wait a few seconds for it to stabilize, and press the read key. Now, if using an external software program, a printer, or a PC-based data collection routine, we can take multiple readings of the sample, and the statistics based on the sample identification will be automatically calculated by the system. The ability to get such data without the need of an external PC is a valuable option for those companies doing pharmaceutical, food, or consumer product material where the CFR requirement may become an issue. As you can see by the reproducibility of these readings, again, our stability is excellent. And it's good laboratory practice at the end of running a sample to take your sample line off the nebulizer and put it in your blank to rinse out any sample to avoid any buildup of solids. Press the escape key to check your blank reading, and you can see it drops down to 0 very quickly. All solutions should contain at least 1 or 2% of acid to prevent hydrolysis and keep everything stable. At this point, we can take our sample line out of our water blank, let the nebulizer run dry, shut off our acetylene gas, wait a second or two, then shut off our air, and our analysis is complete. We can turn off the instrument at this point, or if we're going to come back to it in the near future, turn off the screen contrast, thus keeping the hollow cathode lamps warmed up, which will allow them to be powered up instantly for future analyses. The Buck Scientific 210AA platform is extremely adaptable and can be upgraded to a graphite furnace AA for part per billion, part per trillion level work, our combination hydride generator cold vapor system for arsenic, selenium, antimony, and mercury determinations at the ppb level, or for nitrous oxide or even argon hydrogen flames for specific analyses. Buck Scientific also offers a semi-automated AA called our Model 210, which includes automatic ignition, automatic setting of gas flows and switchover from air to nitrous oxide flame, the safety drain, burner block interface, and a variety of other safety features for operations that require such control of their AA systems for insurance or safety purposes. For basic industrial applications, or ideally for academic situations in teaching laboratories, our Model 205 Basic Flame AA provides the simplest of operations, yet providing fairly high quality data. The system cannot be upgraded and does not have background correction, but will still provide excellent data for certain analytical situations. For mercury analysis in drinking water, food materials, or any products where you have to get down to 10 to 25 part per trillion detection limit, the uniquely designed Model 410 cold vapor mercury system will allow you to reach these levels with the ability to background correct away any interferences from organics, water vapor, or acid vapor by using the same deuterium background correction as the 210 AA platform. The unique mercury lamp, designed by Buck Scientific, provides an extremely high output and stability, and the very long path length 400 millimeter cell is unique to the 410 and provides that low part per trillion sensitivity.